Our next section is on evaluating functions, and when we evaluate functions, we use something that's called function notation. And function notation is a shorter way of writing word descriptions of functions. So our f of x, that's how you read this right here. This little symbol means f of x. That's how we read it. And this is an arrow here, even though it doesn't look like one. F of x represents the range, remember range is our y, of a function. So f of x is just another way to write y. So I know a lot of people get confused when we start using f of x, and you have to remember that f of x is just your y. It's a different way to write your range, which is your y. So we are going to evaluate these functions the same way we would as if we were writing y instead of f of x. So to evaluate a function in function notation, you're going to substitute for the x value to find the range. So for number 1, if it says evaluate the function f of x equals 2x plus 3 given f equals 7. This right here, this function notation, tells me my x value is 7 because this 7 right here is my x. So when I plug in 7, I get f of 7 equals 2 times, now instead of writing x, I'm going to write 7 plus 3. And then I'm going to just evaluate this side. I don't need a parenthesis there. So I have 2 times 7 is 14. And I still have f of 7 on this side. Now remember, this is not f times 7. This is f of 7. It is function notation. This f of 7 here is still my y. So treat it just the same you would as if it was a y. So when I finish solving this, I get f of 7 equals 14 plus 3 is 17. So this is my answer right here. My range, my f of 7, or my y, equals 17. So I can write that as a point now, my xy point, where my x is 7, my y is 17. Okay, so now it says evaluate the function g of x. So just because we're using a different letter here, we're still using our function notation, so it's still going to be the same thing. This right here is our y. That's what this means. I'm going to write a little parenthesis here. That is our y. We're thinking of g of x as our y, our range. Now if g of 3 is given, we want to figure out what that is equal to. So g of 3 means we're plugging in our 3 for our x values. So that means we're going to have 3 squared minus 4 times 3. When we simplify this, we get g of 3 equals 3 squared is 9, 4 times 3 is 12. And I can continue to simplify. 9 minus 12 gives me negative 3. So this is my answer here. And I can write my final answer as a point. So if I have my x is 3 and my y, when that x equals 3, that's what I just solved for, is negative 3. Okay, let's try 2 more. Evaluate the function h of x given h of negative 6. So this is our given here. So what does our x equal right here? Our x equals negative 6. So we're going to plug in our negative 6 into our equation. H of negative 6. So when we evaluate this function, when h equals negative 6, we get negative times, we plug in a negative 6 plus 5 times a negative 6 minus 2. So we got to be careful with our negative signs here, because if we have a negative sign in our original function, we need to have that negative sign plus the negative sign in our x that we're plugging in. So when I simplify this, we get negative times negative is positive, so I have 6, and I have 5 times negative 6 is negative 30 minus 2. H of negative 6 equals 6 minus 30 minus 2 gives me negative 26. So my final answer, when x is negative 6, my y equals negative 26. Okay, we've got one more. Evaluate the function f of x when x equals negative 3/4. So this is my x. My x equals negative 3/4. So if I plug that in, f of negative 3/4 equals 2 times a negative 3/4 plus 3. I can simplify this. I get 2 times negative 3/4. You can either do this in your head or on your calculator. We get negative 6 over 4 Negative 6 over 4 is equal to negative 3 over 2. When I add 3, plug that into my calculator, I get my f equals 3/2. F of negative 3/4 equals 3/2. So this means that when x is negative 3/4, my y is 3/2.